after the last class, Mas Atoka dash the students X naira. And they give option. Listen. Option A, 1,000 naira. Option B, 1 million naira. Option C, 1 billion naira. Please. $150. Oh my God. So you're saying Master Paka can only ask somebody advice.
Master Paka, this one know you well. He said I'm begging the Dutch people.
Master Paka is like shocked. See how I want to be back. Because I don't like showing my Master Paka is a secret giver. He does not like you.
Jesus. Onaga. What happened?
Okay. So now having explained that well, any other question? Yeah, question.
What's up? What happened? I'm police. Yeah. Thank you.
Now, you can't do it easy. If you condense that equation, if you condense equation 1, you take equation 2. Just that lambda. Lane 2. Your lambda is lane 2. Your lambda is lane 2. Your lambda, your 0.693 is lane 2 over lambda. Yeah? In other words, lambda is equal to lane 2 over 2 half. That's what I'm telling you now. You cannot see it. Okay, see it now. No, see it now. See it now. If you do this now, somebody is calling our attention to something. See, look at it. Since you have that T half is ln 2, okay, ln 2 over lambda. Since you have that T half is ln 2 over lambda, is lambda not equal to ln 2 over T half, right? Lambda is ln 2 over T half, is it not true? Now, if you put it into this equation, okay, what you have, ln over any 0 is equals minus lambda T, lambda minus lambda T, is it not true? Then lambda, you can put this into the here. So what are you going to have? Ln over any 0 is equal to minus what? Minus ln 2 over what? Over T half, is it not true? T half multiplied by T. T half multiplied by T, see me? See your lambda now, see your lambda. Your lambda is everything here, which is this. Okay. Is it not true? So if you put this down, you have this. Okay, you have this. So what you have here now, you can solve it around. Then this negative, of course, you can put this equation into so many things. You can put this equation into so many things. Into so many things. The negative here can make this. This can become now ln n0 over n, which I've told you before, is equal to, then you have ln 2t, okay? Ln 2t divided by what? Divided by t half. Okay? Then you have this equation. You have this equation. Okay? This equation. You have this equation. So somebody can even, in one step, somebody can still do this equation we did in one step. If you use this equation the way it is, the way this equation is now, you can do this thing in one step. The way this equation is looking, you can do this thing in one step. Because you have everything inside here. You have your n0, you have your n, you have your t, you have your t half. Just put in everything here, okay? And cook the whole thing. What do you have?
You wrote your name down.
Equals 2 raised to power what? T over half life.
Okay, it's okay.
If you solve this thing further, you can still get to that.
No wonder you are hearing.
Does it make sense? You can transform the equation into anything at all. Does it make sense? Did you solve the equation using your own equation? Solve the equation using your own equation. Did you solve the equation using your own equation? Solve now. What do you have? 5.25. The important thing is that you get your answer. True or false? Whatever equation you want to use. Okay? As simple as that. Now, question again, yeah? Question, yeah? Do you see question 68 on that same page 9? Do you see question 68?
Got it.
When a radioactive nuclide emits a beta particle, its atomic number increases by 1, its mass number decreases by 1, its atomic mass increases by 1, its atomic number remains the same. Which one is the answer? When a radioactive nuclide emits a beta particle, its atomic number 68, page 9. Its atomic number decreases by 1. Its mass number decreases by 1. Its atomic number increases by 1. Its atomic number remains the same. You remember group displacement theory? That's the answer to this question. What did I tell you happens with beta particles? When a beta particle is released, what happens to the atomic number? It gives you the daughter nuclei is one place to the right. And even when it is one place to the right, what happens? It increases by 1 now. Is it not true? It increases by 1. So if a nuclei is 80 and emits a beta particle, then the daughter nuclei will be what? 81. Is it not true? That is an increase by 1. So don't mind all the other rubbish, the questions, all the other questions are saying. Okay? So moving forward now, let us see. So write for me uses of radioactivity. Uses of radioactivity.
Now, no wonder you are shining today.
Another question.
Rana,
There are so many
welcome.
other questions. Okay? You have to go through. You go through and then you see and then you come back to me. So uses of radioactivity. Uses of radioactivity. Uses of radioactivity. Now, let us discuss this. Number one, we have talked about determining the age of materials or artifacts. Number one, determining the age of artifacts. Okay? For the determination of the age of artifacts. So you can use radioactivity to determine the age of artifacts. Okay? Age of artifacts. A-R-T-E-F-A-C-T. Artifacts. Artifacts for things that are kept for long, okay? For historical reasons. okay, for historical reasons. So we can use radioactivity to determine the age of artifacts, okay, by way of carbon dating, by way of carbon dating, by way of carbon dating and other dating. I told you it's not only carbon. We don't date only carbon. Okay? We don't date only carbon. We can date all other elements. Okay? We can date other elements. So, by way of carbon dating. Now, listen carefully. Let's see so many uses. There are so many uses. Okay? There are so many uses. Now, you can use radioactivity to elucidate. Number two, elucidation of mechanism. Elucidation of mechanism. E-L-U-C-I-D-A-C-I-O-N. Elucidation. For the elucidation of reaction mechanisms. For the elucidation of mechanisms of reaction mechanisms. Okay? Elucidation of reaction mechanisms. Look at this man. Man is down Okay, the meaning of elucidation. Now, let me give you an instance. It is a mystery. Something you don't know is a mystery to you. Is it not true? Yes. For example, how is it that I pour this particular thing into this? I pour two transparent substances, and then the two of them react, and then I have a colored substance. You see that now? Now, it is a mystery to you, for you to understand how these two things react in order to give you this order. Now, elucidation simply means you want to study this to the atomic level to understand what actually happens, okay, when the two of them come together in order to give you this other new product. Does it make sense now? So I want to elucidate. So to elucidate mechanism, okay, mechanism in chemistry, whenever you hear mechanism is simply, we want to know how this thing happens. How does it happen? How is it that this thing reacts with this? So give us the how does it happen? Okay? Now, some of you we often tell you that this reacts with this. If HCl reacts with the other one, they are going to form this. How do we know? How do we come to know all of that? You can only establish that knowledge by what? By way of elucidation. So, by elucidation is an English word. Okay? So try to study the pattern. You are trying to study the pattern of something so that you can come out with a general rule that this is how it happens. Okay? So that's elucidating reaction. You want to elucidate any reaction at all. Simply means you want to study what happens so that you can understand how the reaction occurs. So reaction mechanism in chemistry, for example. Okay? Let me give you an instance of what I'm talking about. Now, for example, look at this now. You were told that if an alcohol reacts with this, okay, this OH, okay. So you are told that if an alcohol, okay, ROH reacts with this, that what will happen? That you are going to form an ester. Is it not true? That you are going to have RC double bond O, then OR, then plus what? Plus water, plus H2O. Now listen carefully. See the problem we have. This is alcohol. ROH is alcohol. Okay, this is an alcohol. This R is alkyl group. This R stands for alkyl group. Okay? By alkyl group, I mean, for example, CH3. Okay? So if I put CH3, for example, that will be CH3OH. And that will be methanol. Is it not true? So this will be methanol. Okay? Now, look at the problem now. Look at the issue. We do not know. We do not understand how this reaction occurs. Okay? We do not understand how this reaction occurs. Now, does this reaction occur as this? The OH, does the OH here, move away and then react with bond to the hydrogen here, to this hydrogen? Is it that this OH goes away with this hydrogen, breaks away with this hydrogen, and then forms one molecule of water, and this OR now takes the position of this place to form this ester? This is an ester, okay? We don't understand. There are two ways this particular thing can form. It's either the OH bonds with the hydrogen here, or it is that the H here went away and bonded to the OH here to form the water, and then the arrow now attached to this place. Does it make sense to you? Yes. So we don't know which one happened. Is it the alcohol, is it giving OH to this, or is the H only the one that goes away and bonds with the OH of this? We are confused about that. So the only way we are left with to study how this reaction occurs is to use a radioactive oxygen. Okay, we can use a radioactive oxygen to prepare this methanol, to prepare the alcohol we want to use. I hope you know that I told you before now that there are things called radioisotopes. Is it not true? Yes. For example, there are certain oxygen atoms. There are isotopes of oxygen that are radioactive. Just like I told you that there are isotopes of, there is an isotope of hydrogen that is radioactive. Is it not true? And that is tritium. Tritium is radioactive. Is it not true? So if I want to study any reaction, where I want to understand which of the hydrogen moved, is it this hydrogen from here or the hydrogen from here that actually moved, I can simply use radioactive hydrogen, the isotope of hydrogen that is radioactive, to prepare that particular sample. By using it to prepare that sample, at the end of the day, at the end of the reaction, if I found out that this particular substance, this particular product is radioactive, what does it suggest? It suggests that one of the atoms that I marked to be radioactive was the one that was deposited into the new compound. Is it not true? That is what we call elucidation of reaction. We want to understand how a reaction occurs. So we do what we call radioactive marking. We do marking. It makes some sense now, right? Okay. Number three.